All right, so last week we started our 2.2 notes. We went over our definitions. We went over how to find our slope by finding rise over run. Okay. We talked about what a positive slope looks like because you read it from left to right. So if you read this from left to right, it's going down, so that's a negative slope. If it was going up and to the right, like this one here, that one would be a positive slope, a negative slope, a positive slope, a negative slope. We talked about the difference between that. We talked about how to use the slope equation or formula, the difference of your y values over the difference of your x values in order to find slope. So from 2 points here, we figured out how to calculate slope. We figured out, remember we talked about the ski stories? So those horizontal lines, you can still ski across a flat surface like this, but it's zero fun. When you try to ski down a surface like this, it's not going to work out very well, and your ski trip, you probably won't remember it if you do survive, and so your ski trip will be undefined. We talked about how to graph based on the slope. So if your slope was 1/2, you'd be going up 1 to the right 2, up 1 to the right 2. Okay. Negative 3/4 would be down 3, right 4, down 3, right 4. Or you could say up 3, left 4, up 3, left 4. Does that all sound familiar from what we talked about last week? Get some pen nods, okay. Let's see what we have on the back side. We started with there are 3 forms that you can write a linear equation, 3 types of linear equations, 3 forms you can write them in. And the first one was slope-intercept form, and that's what we talked about first. That's the y equals mx plus b. M is going to be the slope, and your y-intercept is 0, b. We're going to add in the next 2 forms right now. So the next one is point slope form. And point slope form is y minus y1 equals m times the quantity of x minus x1. Now to be an equation, it has to have an x and a y in it. Okay? So in this one, you'd have the x here, the y here, the m is a number, and the b is a number. Are you with me? So an example would be like y equals 4x plus 7. Okay? In this one, your y is still a number, your y is still y and your x is still x. This y1, though, will be a number. This x1 will be a number. And that m will still be a number. Okay? The m is the same thing as it was before. What was m before? Slope. So it's still going to be slope. Now, the x1 and the y1 come from any point. Any point on your graph you can use is x1, y1. But the way they show up in the point is going to be opposite from how they show up in the equation because of those subtraction signs. All right. So we'll scoot down to example 2 right here because then I can actually show you an example. We already started on example 2. We had already found the slope and we filled in a couple things. We started graphing it. But in this, it starts by giving us a slope and a point. The easiest form to write based on the given is point slope form. Now imagine that. The name actually tells you if you're given a point and a slope, probably go to point slope form. Okay, so point slope form, remember that said y minus y1 equals m times x minus x1. So we have y minus, what was y1? What's the y value in your point here? 4. So it's going to be y minus 4 equals the m, what was the slope? 7. So we're going to fill in 7. X has to be there. Remember, your x and your y are still going to be in any equation. Minus, what's the x in the point? 3. So x minus 3. And that's your point slope form. Now, if this was a negative 4, what happens when you subtract a negative? It's positive, so instead of saying y minus 4 here, if that was a negative 4, this would become y plus 4. Is that okay? All right. So that's an example of point-slope form. Standard form is going to be the last one. Okay? And your standard form is going to be written like this. A is going to represent a number. Oh, I should do it a different color than what I've been doing. Okay. A is going to represent a number times x. Remember, every equation has to have an x and a y in it. Plus b times y, so a number times y, equals c. Now, it is important that you represent those as capitals, okay? Because a, b, and c, that set of numbers has to be an element of, okay? So a, b, and c have to be a part of the set of integers. There are those number sets that we talked about in Unit 1. What numbers are integers? What are integers? Uh-oh. We got to know what integers are. Go back to your Venn diagram if you don't know. Yep, negative numbers and positive numbers. Does 3/4, is that an integer? No, because that's a fraction. That's rational. Okay? Integers are your positive and negative counting numbers. Okay? So, A, B, and C have to be positive or negative counting numbers. That means they cannot be fractions. I would probably write that down right there if you didn't know what that symbol means. I'm not going to write it down because I already know what integers mean, and I know I use that symbol because that's what an integer is. But if you don't know that symbol means integer, I would at this point write down integers and write in parentheses, no fractions allowed, or decimals. Okay? Or maybe write down what integers are, the -3, -2, -1, 0, 1, 2, 3, dot, dot, dot on both ends. Okay? So what we're going to do then is we have to change. We'll look at this example 1. We started this example because it already gave us slope-intercept form, so that was easy to get. We found the y-intercept. We found the x-intercept. We figured out what the slope was. That was easy from the equation. Parallel slopes were the same slope. Perpendicular slopes, how do we figure out the perpendicular slope here? How do we go from -1/2 to 2? Opposite and reciprocal. So you change the sign and you flip the fraction. Okay. What we didn't find yet is standard form and point slope form. Okay. So which one do you want to do first? It does not matter. Let's do point slope form. And there are infinite number of points on the graph because this line goes on forever. And even between the points that we marked on our graph are infinite number of points. So you can pick any point you want. It doesn't matter. Okay, so maybe you want to pick this point right here. What is this point right here? What coordinate point is this? -4, -2. Okay, so if we use the point -4, -2, I just picked a random one. You do not have to pick any specific one because this works with any point. There's my point. What's my slope? Because those are the two things I need to write this form. What's my slope of this graph? -1/2. I already talked about that. Okay, so there's my point. There's my slope. All right, now we can write point slope form. So I'm going to write y. I have to write y in there. Minus y1. So what's that going to turn into based on this y here? +2. If it's minus -2, it turns into +2. Equals, the m is -1/2 times x minus, what's our x value? -4. So x minus -4 is going to turn into what? X plus 4. and that's it. Now you wrote it in point-slope form. Now let's say we didn't have slope-intercept form. You could have taken this. You could have moved things around by distributing that negative 1/2, by subtracting 2 on both sides, and you would have gotten y alone, and then you would have had slope-intercept form. Okay? Notice standard form, the x and the y are on one side. So let's use our slope-intercept form. Let me box this in so we know that's our final answer here.
Last call for count sheets. Please take your count.
So here's our point-slope form. Here's our slope-intercept form. We still have to get standard form. Okay? Standard form has the x and the y all on one side. So I can take this equation. Usually from slope-intercept form to standard form is probably the easier one. Okay? I have to put x on the same side as y. So how do I move that from one side to the other? Add the 1/2 x on both sides, right? So when I do that, those are different terms. So it's going to turn into 1/2 x plus y equals -4. That's very close to standard form, but you would still lose points. Your a value is 1/2, your b value is 1, and your c value is -4. Why would I still lose points? What do your a, b, and your c value have to be? Integers. Is 1/2 an integer? No. So what can I do to this equation so I can get rid of that fraction? Multiply everything by 2. So that 2 has to go to every single term. Okay? I multiplied technically on both sides. I just wrote it all as 1. So 2 times 1/2 is 2 over 2, which is 1. So we have x plus 2y is equal to -8. That is going to be your standard form. That's your standard form. And I think the example 1 is done. Questions on that one? Yes?
Why do you have to have integers?
Because that's what the standard form says. Standard form says that it's written as ax plus by equals c, and there's no fractions. They're written as integers. A, b, and c are written as integers. It's kind of like, why is m slope? Because some old guy really long time ago probably made it up, and it's stuck and has followed through in math and ever since. It's just standard. That's what we do. Yes?
So, you can graph standard form and then do like the same as point slope.
So you can. Okay, point slope form is easy to graph from because you know where the location -4, -2 is.
Yeah.
So you could start with plotting that point, and then from there you can use the slope to find other points and then connect the points. Does that make sense? Standard form is really easy to find your x and your y intercepts. Remember here, we plugged in 0 for x, or we plugged in 0 for y to find our x and our y intercept. When you plug in a 0 here for your x, some people call it the cover-up method because that term goes away. So if you plug in 0 for x, you get 2y equals -8. So divide both sides by 2. Y is -4. 0, -4 is our y intercept. You could plot that point. And then you could go back and say, okay, if I plug in 0 for my y, this term goes away, so cover-up method. X equals -8 tells me that the x-intercept is at -8, 0. And once you have those 2 points, if you plot those, you can connect them, and then you'll be able to find more points because you'll, again, have that slope. Does that make sense?
Yeah.
So that's why the other day I said that someone by the name of Joseph might go by Joe or Joey, right? But they're all the same person. This is all the same function. It's all representing the same things, but there's many different ways to look at it. Are we okay with that? So we'll look at the next example. The next example gave us the slope and a point. We wrote the point slope form. Do we remember how we came up with the slope-intercept form in this one? Do we remember that? We did it by the graph. We said, okay, if we plot 3, 4, and we go with the slope, then we had to imagine where our next couple points would be because we ran out of graph. Do you remember that now? And we said, okay, so our y-intercept would be down here at -17, and then that's how we wrote our slope-intercept form. But there are more ways than just visualizing on the graph that we could have come up with that. You could have taken this and had y minus 4 equals 7x minus 21. So distribute the 7. Are we okay with that? Add 4 on both sides, because we're getting y by itself. And there we go. We have slope-intercept form. So slope-intercept form is just having y alone. Y is on the left side all by itself. And in it, you can see the slope. You can see the y-intercept. Okay. This one, we can change it to standard form. What would I do to make it standard form? Go ahead. How about subtract 7x on both sides?
Yeah, sorry.
Okay, so then on this side we'd have -7x plus y equals -17. What else do I need to do? Trick question. There is nothing else to do. Why? Why is this one so much easier than the last one? Why is it already done? Go ahead. They're already integers. -7 is an integer, 1 is an integer, and -17 is an integer. We don't have to worry about multiplying by anything to deal with just integers. So that's our standard form. -7x plus y equals -17. Now remember, your x-intercept is at x comma 0. Your y-intercept is at 0 comma y. Okay, so on this one, if we don't know what x is, that's okay. Plug it into, I would plug it in here to my standard form, because if you plug in 0 for y, we're going to have -7x equals -17. Right? Because that term goes away when you plug in 0, that y term. Divide both sides by -7. A negative divided by a negative is positive. 17 over 7, though, doesn't reduce, so I'm just going to leave it like that. And the way I write the point, though, is 17 over 7, comma 0. Now, if I were to try and graph from standard form, this one would be very difficult, because if you had a graph 0, -17, and then graph 17 sevenths, comma 0, notice where that point is. It's not a very obvious location. So I wouldn't trust graphing this one from the two intercepts, because this intercept is going to be hard to graph. If it was a nice number, I would say go for it, but this one is not a very nice number to put on a graph. Is that okay? Go ahead.
Why would you do -7x divided by -17? I just looked at the graph, saw that it went through 2, and 2.
It goes through 2 what?
2, yeah.
It doesn't go through 2, 0, though, because it's saying where does it hit this x-axis, and this is where it hits the x-axis, is beyond 2. But we don't really know where in between 2 and 3 is it hitting. So you can't use the graph in this one because it doesn't hit it in a nice spot. It's not exactly at 2, 0. It's not exactly at 3, 0. And it's not at 2.5 either. So we had to plug in 0 to our equation so we can figure out exactly where does it hit on that graph. Does that make sense?
Yeah, so Where did you get -7?
Because we plugged in 0 for y here, so negative 7x plus 0 equals negative 17. I just didn't write the plus 0 part in because it's not necessary. Does that make sense? So I used my standard form. You could plug it into any of these equations. So you could have plugged in 0 here, but then we would have had to add 17 on both sides and divide by 7. They would have just been more steps. Because in either of these ones, you have to move things to other sides usually. Yes?
I'm confused because in the beginning it was just 7 and not -7. How did you get
Because you have to subtract 7x on both sides. Because we had slope-intercept form, the slope is positive 7x, yes. But you have to subtract 7x on both sides in order to get negative 7x plus y equals negative 17. So that's where we plugged it in. It was up here in standard form. Okie doke. Other questions? No? Are we feeling okay with this? We're going to do lots more examples, so don't be freaking out and be like, whoa, 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 which steps do I take? We have lots more examples together, and you guys have lots of examples on your own to work through as well. All right, so let's flip the page. What form did they give us in this example 3? Point slope form. So I'm just going to take that, I'm going to write it down here in point slope form. And maybe it might be easier if I write out what's my point and what's my slope, so I can actually maybe put this on a graph or something. So what point was used to write this equation? Remember, they show up opposite in the equation than they do in the actual point. Go ahead.
-3, 6.
Yes, -3, 6. So your x is with your x, but shows up opposite. Your y is with your y, but shows up opposite. Okay? And what is the slope? Positive 1/2. Now, you can, well, we found the slope. I guess we can write it up here. You can decide where you want to go next. You could graph it. You could work at taking this equation and changing it so it looks like slope-intercept form. You could take that equation and change it so it looks like standard form. So where do you guys want to go? Slope-intercept? Okay, so what do we have to do in order to make this look like slope-intercept? Get y by itself. Okay? And we also are going to have to get rid of those parentheses, right? So to go from point slope, I would first distribute that 1/2. I can rewrite it over here. So that 1/2 is going to distribute. One times 3 is 3/2 still. So remember, this is just 3/1, and when you multiply fractions, you just multiply on the top, multiply on the bottom. Okay. Then what? Add 6 on both sides. When you add 6, that's the same thing as adding 12/2, right? 6 is the same thing as 12/2. So I just made it so that there's a common denominator. You probably are going to have to do that at some point. So that's going to be 15/2 now. And y is alone, so that's your slope-intercept form. What does your slope-intercept form tell you? There's 2 pieces of information in your slope-intercept form, and it tells you right in the name. The y-intercept and the slope, okay? So what is your y-intercept here? Remember, we have to write it as a point. Yep, 0, 15 halves. Because your y-intercept is always 0, comma y, and your x-intercept is always x, comma 0. It might help you if you write those in. And if you weren't sure what it was, you could have plugged in 0 here for x, and then it turns into 0 plus y equals 15 halves. That's how you know what y is. All right, so there's slope-intercept form. We still need our graph, we still need standard form, and we still need our x-intercept. Where should we go next? Standard form? Okay. So do you guys want to find standard form from slope-intercept form or point-slope form? Honestly, it doesn't matter. But if you do it from point-slope form, you're going to first get it to here and then move it to standard form anyways. So I would take it from slope-intercept form. So I would start with y equals 1/2 x plus 15 over 2. And what do you guys want to do first? What are we going to do? Well, standard form looks like this. You can always write it down if you're not sure. Ax plus by equals c. So we want it to look like that. Subtract what? Yeah, subtract that 1/2 x first on both sides. These are not like terms, so they're not going to combine. We're going to get negative 1/2 x plus y equals 15 halves. Okay. Do we have to take this one more step? Yep. Go ahead. What is it? Multiply by 2. Yeah, times everything by 2. So we're going to multiply this term by 2, multiply that term by 2, multiply this term by 2. And we're going to get negative x plus 2y equals 15. And that's your answer. Okay. Should we graph it or should we find our x-intercept? Okay, let's find our x-intercept then. What do you want to use to find the x-intercept? And there is no right answer. I'm asking these questions, but there is not a right answer. You can find the x-intercept using the graph, if we had it. You can find the x-intercept using standard form or point-slope form or slope-intercept form. Which one do you want to use? Standard form. Okay, cool. So that means that our x is going to be, that's what we're solving for. So we have negative x plus 0 equals 15. Well, I don't need to write plus 0, so I'm just going to write negative x equals 15. Oh, wait, I'm just dividing both sides by negative 1. X equals negative 15, which means my x-intercept is negative 15, comma 0. And there's my x-intercept. Are we okay with how I did that? Go ahead.
How did you get 0?
Well, because 2 times 0 is 0. I plugged in 0 for y, right? Your y value has to be 0.
Oh.
So when I plugged in here, negative x plus 2 times 0, I knew was going to be 0. So I just wrote it as 0 equals 15. And then that doesn't mean anything, so negative x equals 15. Is that okay?
Yeah.
Okay. And if I would have written it the one step sooner, I would have wrote negative x plus 2 times 0 equals 15. So you're just plugging in a 0 for the y value. Okay. Oh, you guys saved your favorite for last, right? Graphing? So let's see. Let's put, we're at positive numbers a lot, mostly, so. Okay, I'm going to go up by 1s on my y, but I'm going to go up by 2s on my x scale because I want to get over to negative 15, 0 so I can graph my x-intercept here. So negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16. This is f4. So I did that just because I wanted to make sure that I graphed both my intercepts on here. Because I was kind of looking and saying, okay, I want to plot where 0, 15 halves is. I want to plot where negative 15, 0 is. I know I'm going to have a slope of 1/2. So I was kind of just taking my pieces, and that's how I figured out where I wanted my axes to go. Okay, so then for my graph. 0, 15 halves. 15 halves is just 7.5, right? So 0, 7.5. If this is 6, that's 7. 7.5 is right in between. I'm just going to plot all the pieces of information I have. I have negative 15, 0. So this is negative 12. This is negative 14. This is negative 16. So negative 15 is going to fall right in between the two. There's another point that I have given this information. What's another point that's on the graph? Go ahead. Negative 3, 6. Very good. So negative 3 is going to be right here. 6 is right here. So I'm going to plot that point. Okay. What should my slope be? What's my slope supposed to be for this graph? Rise 1, right 2. Well, why is it that I'm not going up 1, right 2 on this graph? Why does it not look that way? What do you think?
Because the way you set up the graph, not every like line is just a single number.
Yes, not every line, it's not, the units is not 1. So it's not going up 1, right 2. You have to go by the scales on your axes. That's going up 1, right 2. So if here I'm at 6 and I go up to 7, but I go right 2 is actually only right 1 on my graph because of my scale is 2s. So I'm going up 1, right 2 would actually be right here. Up 1, right 2 would actually be right there. And yes, that does fall in line then. Okay, so going the other way. Down 1, left 2. 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 And eventually I would have hit that other point also. So just because it doesn't look like it has a scale of 1/2, it does. It's because my scale is not just 1. So there's my graph for that. Okay, we ready for the next one? Now this next one, it says write an equation of a line through the point 410, and it has to be parallel to this line. Okay? What is the slope of that line? -3/4. So what's the slope going to be of a line parallel to that? Parallel means they have to have the same slope. So our slope has to be still -3/4. I am done with that information. I don't even want to look at that equation anymore. Okay? You're done with that equation now that you have what the parallel slope needs to be. Okay? I would probably choose, because it tells you that it has to go through this point, and it gives you a point, and you found the slope, I would probably go to point slope form first. Because they gave you the point is 410, and we figured out that our slope needs to be -3/4. So we'll write that form first, and then we'll find the other forms to it. So this one's going to be y minus 10 equals -3/4 times x minus 4. So far, so good. Okay, what do you guys want to find next? Which one? Want to find your intercepts? Sure, you could do that. So plug in your zeros. I don't like to plug in zeros for the point slope form because it's a lot of solving when you do that. But you totally can. Go ahead. You can find slope intercept form. Okay, so what would we do to find that?
We would add 10 to both sides.
Okay, so we'd have the y minus 10 equals -3/4 times x minus 4. Add 10 to both sides. Adding 10, there's no like terms right here that you can add it to, so we're going to get y equals -3/4 times x minus 4. Plus 10 will be down there at the end. Okay, that's not quite slope-intercept form though yet. So what else do you have to do? Distribute. Y equals -3/4 x. -3 times -4 is +12. +12 divided by 4 is +3. Okay, then what? It's looking a little better. Go ahead, what do we do next? Combine like terms. There you go. Y equals -3/4 x plus 13. All right. What should we do next? Go ahead.
Standard form.
Okay. How are we going to get to standard form?
You would add 3/4 x first.
Okay. So we're going to start with this one. So you're adding 3/4 x on both sides. So we have 3/4 x plus y equals 13. So far, so good. Something else we still have to do? What are we going to do next? Make them integers. Yeah, 3/4 is not an integer. So you need to make all of your coefficients integers. So what are we going to have to multiply everything by? 4. And that's why last unit we practiced getting rid of fractions in some of those solving, because we have to know how to get rid of fractions is by multiplying everything by that denominator. So this one we're going to get 3x plus 4y equals 52. Their standard form. Okay. Then what? I would find my intercepts now. I'd find one of my intercepts by using slope-intercept form. Slope-intercept form tells you what intercept. What intercept is written in slope-intercept form? The y-intercept. So your y-intercept should be at 0, 13. So we should be able to see that one. But maybe you wanted to use standard form to find it. You could have done that too. You could have said, okay, let's figure out what y is. So I'm going to plug in my 0 here. So I get 4y equals 52. Divide both sides by 4. And you end up with y equals 13 anyway. So 0, 13. Doesn't matter which route you go, you're still going to get 0, 13. And the x-intercept, which is x, 0, I'm going to plug that one into standard form. Again, you could plug it in over here and plug in 0 here, but you'd have to subtract the 13. Then you'd have to deal with that fraction. This one, you could have plugged in 0 for y here, and then you would have had to get x alone. And so there's a lot more steps if you do these routes versus there's already no fractions to deal with in this one. Your y is going to be 0, so 3x equals 52. Divide both sides by 3. X equals 52 thirds. I don't think that reduces at all. So I would just leave it. 52 thirds, 0. And then we can graph this. Maybe I'll go up by ones here. I'm going to go up by 2s on my y because I know I'm going to have to get to 13 here. And sometimes people like to graph the original equation that they had, the one that we crossed off that we forgot about. Okay, some people like to graph that and then find the parallel one. Some people like to do the graph first because it makes sense to them. So this first one was, oh, I guess I did a terrible job for graphing this one. Would have been at -4. 0, -4 for that first point. And then it's going down 3, right 4. So let's see. Down 3 would be like here. Over 4 would be like here, up 3, I don't know, somewhere over here. So this is ish what this would look like, even though it's off my graph. So that's the original equation, okay? So then they want to graph our new equation, which it told us that the point was through 4, 10. So plot that point first. And then our slope has to be -3/4 still. So down 3, remember we changed our scale here. So down 3 is actually only 1.5. Over 4, 1, 2, 3, 4. Up 3, left 4 is right there. Now, do those appear to be parallel? Those look like they'd be parallel? Yeah. Okay, cool. We did that portion of it. All right. And let's make sure that everything matches. Our y-intercept is at 0, 13. Cool, we found that. That matches. If I kept going, down 3, right 4, sure, I'd be at 52 thirds. I know it's positive. I don't know where 52 thirds is. We could find an estimate. Looks like it's somewhere over there. Oh, 52 thirds. Yeah, 17.3 repeated, right? So over here at like 17, sure, it looks like it could hit about there. I didn't graph it, but that's okay. We can kind of visualize where it would be. And I think everything else is looking good. Do we have questions on that one? Okay, so if I flip the page, it says write an equation of a line through 3, -7 and perpendicular to this other one, to this equation here. Now, if it is perpendicular to this slope here is -3/4, but I want a slope that's perpendicular. So what does my slope have to be if it's perpendicular to -3/4? Opposite and reciprocal. So if this one was negative, we're going to make our slope positive. If this is 3/4, we're going to make our slope 4/3. So positive 4/3. Okay, we're done with this. We don't have to think about that anymore. We know that the point is at 3, -7, and the slope is at 4/3. I would probably write point slope form first since I have a point and I have a slope. So y plus 7 equals 4/3 times x minus 3. Okay. I'd probably go to slope-intercept form next. So we have y plus 7 equals 4/3 times x minus 3. I would distribute that 4/3. -3 times 4 is -12. -12 divided by 3 is -4. Okay, well, y has to be by itself for slope-intercept form, so subtract 7 on both sides. Four-thirds x minus 11. All right. That looks all right. What should we find next? Actually, we have something based on that. What do we have? Y-intercept. What's our y-intercept going to be? 0, -11. The y-intercept is the b value of your slope-intercept form, so you already have the y-intercept there. All right, let's go to standard form next. Does that sound okay? So I'd probably use my slope-intercept form. What should I do first? For standard form, what am I going to do? Subtract that 4/3 x, move it to the other side. So now I'm going to have -4/3 x plus y equals -11. All right, that's still not going to get me full points though. What do I need? Multiply everything by 3. Then I get -4x plus 3y equals -33. Find the x-intercept by plugging in 0 for y. Doesn't matter which equation you use. I prefer to use standard form, but it's okay if you choose something else. Makes that part 0, so negative 4x equals negative 33. Divide both sides by negative 4. I know a negative divided by a negative is positive, but other than that, you can't simplify that anymore. So 33/4 comma 0 for my point. So next we have the graph. So when you go to do this graph, you can graph it from any of the equations. You could graph it by using this original one and then plotting that point and changing the slope like what we did with the parallel. But it doesn't really matter. So let's make sure negative 11 is on our y. They give us 3, negative 7. So we'll equal. So we'll go by 1s on here. And we'll go by 2s on this one. Now the original was -4, and then it was down 3, right 4. So remember, you have to go by the actual scales you chose, not by just counting down 3. So this here was your original. And this one, we are going through the point 3, negative 7. So right here. And this slope is going to go up 4, right 3. Then I'm just going to double check that when I graph this, that it actually goes through my y-intercept. Like I said, it was supposed to go through 0, negative 11. That looks good. It's going up 4, right 3. It's going through that point that it told me it has to go through 3, negative 7. Now, why do these not look perpendicular, though? Because do those look perpendicular? Do they look like there's a 90-degree angle there? No. And if you think about it, we actually stretched the graph one way. So think about like a picture, and if you were to stretch it one way versus the other, it would get distorted, right? And then people look funny in pictures when you distort them and you stretch them one way or the other way. And it's the same idea with angles. If you don't stretch it on an angle and stretch both the x and the y-axis the same amount, then you get this distorted image, okay? And that's the same thing that's happening with that angle right there, is because our scale on our x and our y are not the exact same, you get this distorted image. So if we would have made both scales 1 or made both scales 2, then it would have looked perpendicular. But that's okay. I mean, it just wants us to graph the line that is perpendicular, and that is the proper line that we graphed, even though it doesn't look perpendicular in the way that we graphed it. We have 2 more examples. So it says, write an equation of a line through 2, 8 and perpendicular to y equals negative 3. Okay, so y equals negative 3 says that your y is always going to be negative 3 no matter what your x value is. So let's graph this. Okay, so if I were to graph this original, y equals -3, that is a horizontal line through -3. So here's 2, -3, 4, -3, 6, -3. The -3 is always going to be the same, no matter what the x is. So it's just this horizontal line. It has to go through the y-axis at -3. Okay, so that's the horizontal line it's talking about. Now, write an equational line through 2, 8. So let me plot 2, 8. And this one, we want it to be perpendicular to this line. So if we had a horizontal line, what kind of line would be perpendicular to a horizontal line? Vertical. So all we're going to do is we're going to graph this as a vertical line. This is the new line. Okay. How do I write the equation of this blue line? And these are special equations because they're the only ones that don't need an x and a y. So if a horizontal line was y equals, then a vertical line has to be x equals. And I have to look and say, where does it go through my x-axis at? What number? 2, which is actually shows up in that point as well. X equals 2. Okay. Where's your y-intercept of that blue line? There is none. Where's the x-intercept of that blue line? At 2, 0. So we have to make sure we put it as a point. Okay. What is the slope of the blue line? Undefined. When you ski down that, you're not going to remember your ski trip, so it's undefined. Okay, this next one we're going to do very similarly, except for this one's going to be a parallel. So let's draw this graph. These ones are a little bit easier to sometimes do the graph instead of trying to interpret it. But if you can interpret it and just come up with the equation first, that's fine too. So it has to be parallel to y equals 3. So our original equation, again, is that horizontal line through the y-axis at -3. So it's this line right here. Okay. Our new line has to go through the point 2, 8. And it says it's parallel. So what kind of line is going to be parallel to that horizontal line? Another horizontal line. Okay, so if it's another horizontal line, then how would I write that equation? How would I write this equation? Horizontal lines are y equals. So I'm going to write y equals, and then what does y have to always be? And it tells you right in your point, what does y have to be? 8. So y equals 8 is that horizontal line through the y-axis at 8, and that'll hit that point. What's the y-intercept? Where does that blue line hit the y-axis at? Right here, and that point, remember you always have to write your intercepts as a point, so 0, 8. Where does that horizontal line hit the x-axis at? Never. It's running parallel to that x-axis, meaning they will never intersect. Okay, that's what parallel means. They never intersect. So there is none. And what is the slope of a horizontal line? 0. So m equals 0.